So, hello guys. So this is your humble self, like I used to say, Tutor. So thank you for subscribing to this channel, and I know it will be of a very great opportunity of where you learn a lot. Alright, so today we shall be considering the application of triple integral. Alright, so we have an example here. Okay, find the volume common to the cylinders s squared plus what? Y squared equals to a squared, and s squared plus z squared equals to what? Equals to a squared. Alright, we shall proceed this way. There's something about triple integral. When you're talking about triple integral, this is what we call triple integral, which means you're going to be having the x, or you can start like this, the z, the y, and the x. So at the end of the day, this one is going to remain here, this one comes here, and this one comes here. So that is, by the time you rearrange this, you realize that this one remain at this spot, this one channel here, and this one channel here, which becomes integral of what? Dx, integral of what? Dy, integral of what? Dz. So whatever limit you have in here, this can be x0 to x1, x1 to x2, or let me just use x0 to x1, y0 to y1, and z0 to z1. So this is a typical form of what we call our triple integral. That is by the way. Anyway, back to what we are solving. Alright, so now they said we should find the volume common to the cylinders. So first and foremost, I would like to give us the diagrammatic illustration that denotes this kind of questions. Alright, diagrammatically, we have to show it. So we are having two common cylinders. And how does it follow? It follows like this. Okay, let me adjust it to this point. We are having our first cylinder here. This is our first cylinder, alright? That is our first cylinder. So I can use this one as a breaking line. So let this be my breaking line. So remember, we're having two common cylinders. So the other cylinder goes this way. Alright? This is the other cylinder. So are we together? This is the first cylinder and this is the second cylinder. So I can decide to be like, this is the first cylinder, like it is giving us in the question. So let's displace the first cylinder. What do we have? We have s squared plus y squared equals to a squared. So let this place be my s squared plus y squared equals to a squared. Is that clear? Then what is the second cylinder? This is the second cylinder. This is what we are given. So the second cylinder, we are going to place it. We are going to place it at this junction. So it can be like, let this plate be what? What's the second cylinder? This is it. S squared plus z squared equals to a squared. So it can be at that point. No stress. So one other thing you need to consider is that we can create another oval shape here. Alright, are we together? We can create another oval shape here, so which connects these 2 points together. It is very clear. So we can decide to let this comes out. So this can be our y. So if this be our y, then what happens to this side? So this one becomes our what? Our z. So if this be our y, this one can be our z. So now another arrow is going to channel here. Then we can make that one our y. So we do it in such a way that it comes out through this edge. Alright, so make sure it passes through this side, it passes through this edge here. So this one becomes our x. Alright, so this is a simple diagram that satisfies this cylinder. Alright, let's proceed. Remember that we are told to find the volume common to the cylinder. We are told to find the volume common to the cylinder. You have to consider three conditions. Three things you have to consider. So you have to consider Z. That is, let us consider Z. So let us start with Roman figure 1. Z varies from, so we want to consider the what's it called? We want to consider the limit or interval. The interval of Z. Let us consider the interval of Z. So the lower and the upper interval. So now what will be the lower interval of Z? So from this place we can find our lower interval and the upper interval of Z here. So since we are given that here we can see Z here. Z is present here. So that's S squared equals to Z squared minus X squared. Equals to S squared. So if we have something like this, okay, X squared plus Z squared equals to A squared. If we have something like this, so this is where we have Z to be present. So if we have something like this, we'll make Z something of formula that we're having Z squared is equals to what? A squared minus what? S squared. By the time you square root both sides, you have plus or minus square root of A squared minus X squared. I hope you get it that way. So which means that Z varies from the negative to positive. That is, Z varies from minus square root of A squared minus S squared to what? To positive of this. A squared minus X squared. That is for Z. So for Y now, we have to consider for Y too. So Y varies from, so now let's check for Y. So let's check for Y. So where do we have Y present? We have Y present here, okay? This is where we have Y present. Alright. So at that point we have that we have that X squared plus Y squared equals to A squared. We have Y present here. We want to look for the intervals for Y. So that was Y squared is equals to A squared minus X squared. Alright, so that will be Y is equals to plus or minus square root of A squared minus X squared, which means that Y varies from what? Minus square root of A squared minus X squared to what? Plus A squared minus what? Minus X squared. That's that. Alright. So it will be very easy for us to get for that of even from these both guys, we can get the one for X. We have X here and we have X here. So we can start off with this. Okay. So don't forget that just if you have something like this, just conclude saying that you don't need to stress yourself. Just conclude saying that for X, limit of X or interval of X varies from plus or minus A. From plus or minus A, that is, X varies from minus A to what? Positive A. It is very, very easy. Alright, are we together? So having gotten all these things, it will be much very easier for us to solve the problem. So what now happened? Okay, we are now going to say that volume, the next step is that volume required. Our volume required, remember we are finding the volume common to this cylinder. So what will now be the volume required? The volume required will now be equals to integral of, we are going to start with X. Integral of what is for x? We have minus a to a dx. Integral of minus a to a dx. Then integral of, then move to y, minus square root of a square s squared to what? Plus square root of what? A squared minus s squared. This one is the y. Then we move to integral of what? For z now, that's minus square root of a squared minus s squared to square root of a squared minus x squared dz. It's not necessary to put the positive, we know it's positive already. So that way it will be easy for us to solve the problem. So how do we begin to solve? Now if we now solve this one, integral of dz is going to give us what? We have minus a dx, integral of minus square root of a squared minus s squared, square root of a squared minus s squared. If you integrate this one, it becomes z. We have z. So z of what? Z of minus square root of a squared minus s squared, square root of a squared minus x squared. Alright, so we are going to input this guy. So by the time we input it, we have integral of minus a to a dx, integral of square root of a squared minus s squared minus square root of a squared minus x squared. Then this one is, don't forget we're having the y here. So by the time we solve this guy, your indefinite integral. So solving this guy, we have what? Square root of a squared, or let me just do it here to reserve space. By the time we substitute, we have what? Square root of a squared minus s squared. We substitute anywhere we see z, we input the whole of this. Then minus, go back to your indefinite integral. I mean, is it definite? I think it's definite integral. So go back to it. So you input it, then you're having this minus a squared minus s squared. This one is having a square root. Alright. So this one is going to be plus. At the end of the day, we're having square root of a squared minus s squared plus square root of a squared minus s squared. So when we add this one together, it becomes 2 square root of a squared minus s squared. So at the end of the day, for this guy, we are going to be having what? 2 square root of a squared minus what? S squared. Are we together? Alright. So at this junction, we bring out these two. This is a constant. So by the time we bring out these two, it becomes 2 integral of, don't forget, this 2 is outside. We open a large bracket. Then minus a to a dx. Alright. So remember we have bring this one to the back. So this one is no more there. So let us keep this guy. So by the time if we integrate this guy, okay, let's proceed it. Or maybe I should just bring everything outside. I should just bring them outside. Okay, let's do it like that. I've brought out these two. So we are left with integral of minus square root of a squared minus x squared, then square root of a squared minus s squared. Alright, we are left with this guy. Alright, so we are having dy. Are we together? So this one can be a constant. This one will also come outside. So we are going to assume this one as well to be a constant because we don't have the presence of y there, right? So we are going to bring this guy outside like as if it's a constant as well. So we are still going to bring it inside back. So we're having 2 square root of a squared minus s squared into integral of minus a to a, then dx. So I have brought this guy outside. It remained the y here. If I integrate this one, it's going to remain y. It's going to remain y. Then y integral of what? Integral of, okay, it's remain y. Then we're having minus square root of a squared minus s squared. Then we're having square root of a squared minus x squared. Are we together? No stress about that one. Alright, so I'll clean this guy down. I don't need this anymore. So, alright, at this junction, by the time we input this one, we are going to, if you do it the way we did the first one, your definite integral, by the time you substitute, it's also going to give you 2 square root of a squared minus s squared, then square into brackets, integral of minus a to a. This one is also going to give you 2 square root of a squared minus s squared. Then we are having the x here, don't forget. So we have already solved for this, so the value of the whole of this is this. So at this junction, we are having 2 square root of a squared minus s squared. Then, 2 times 2 is 4. Alright? So, we can now bring, 2 times 2 is 4. We can bring this one in. We can bring it inside back. We have this. Then by the time we multiply this by this, it becomes a squared minus s squared. Are we together? Then the x. Do we get it that way? Like I use this to it's just like square root of a squared minus s squared multiplied by square root of a squared minus s squared. This one take care of this one. But no, sorry. Square root of this times square root of this is going to give you a squared minus s squared according to your surge. Alright? So that's it. There's no stress about that. Now, what are we left with? We are left with this guy. So I'm going to integrate this guy now. Now we expand this. 4, we keep this. The integral of minus a to a squared minus s squared. A squared comes first, then dx. Minus integral of minus a to a s squared dx. Alright? So at this junction, we are having 4 into what? By the time we integrate this, we are having what? A squared x. Alright? So when we integrate this guy to, what are we having? We are having s squared over what? S squared over s cubed, s cubed over 3. Do you know how I arrived to s cubed over 3? You know the general rule of integral. 2 plus 1 over 2 plus 1. So if you integrate this one, that's how I came about that. So we're having minus a to a here. So which implies, now if we now substitute these guys here, so we are going to be having, this comes first. So anywhere we see x, we are going to input here because we integrated with respect to x. So it becomes what? A squared into a minus a cubed over 3. Alright? So minus a squared minus a cubed over theory. All right. So we are going to be having we're going to be having 4 into a cube minus a cube over 3 minus into bracket. This one is as minus, okay, let's do it this way, a squared into minus a, and this one is minus, so that's become plus a cube over 3. All right, no stress about that. You have to be careful, you have to be very careful. All right, so this one is 4 into a cube, all right, minus a cube over 3. This one minus and minus is plus, then that's plus a cube minus a cube over 3. Are we together? So all right, so we are going to be having 4 into, this one can add this, so we are having 2a cube, then minus what? Minus 2a cube over 3. All right, so that's it. All right, so we expand the, what would be our LCM? Our LCM is going to be, then this one becomes 6a cube minus 2a cube over 3. All right, so we're having, this one becomes 4 into 4a cube over 3. At the end of the day, we're having 16a cube over 3. Therefore, our required volume is equals to this. So that is our final answer. Our required volume ends up to be what? 16a cube over 3. So I believe you understand this question. It is not really hard. So it just looks like abracadabra, but it is not very hard. Anyway, I have the questions for us. So let me write out this question. Let me write. Where do I write it? All right, I will call it. Let me call it. Find by triple integration. Find by triple integration the volume of a solid bounded by the sphere SPHER, bounded by the sphere S squared plus y squared plus z squared equals to 4, and the paraboloid x squared plus y squared equals to 3z. Okay, find by triple integration the volume of a solid bounded by the sphere x squared plus y squared plus z squared equals to 4, and the paraboloid x squared plus y squared equals to 3z. So let's solve that question and drop the answer in the comment section. So if you are going to show me the solution, please, you can forward it to my WhatsApp number as displayed on the screen. So God bless you guys. God bless you. Love you.